It's time for Math with Mr. Young. Lesson 101. Translating expressions into equations. Let's begin with a power-up. You can use the worksheet provided, or simply pause the video and use a blank sheet of notebook paper to answer the problems on your screen. Go ahead and pause now, and resume once you've completed all of the problems in this power-up. Today, we get a chance to review converting percentages into decimals and fractions. An important thing to note about these kinds of problems is what the word percent means. Let's break the word down. You have the prefix per and the suffix cent. Per means for each. Like, for instance, if I said that gas costs $2 per gallon, I'm saying that the cost is $2 for each gallon. The word cent is the root of words like century, which means 100 years. It means 100. So per cent literally means for each 100. 20% means 20 for each 100. 1% means 1 for every 100. And as you can see, I'm translating for each with a division sign. This immediately turns any percent value into a fraction. The only thing left to do is reduce our fraction to the simplest form. 1 over 100 is already in its simplest form. 20 over 100, however, can be reduced. Since both top and bottom numbers end in a 0, we know we can divide both by 10. That gives us 2 over 10. We can still reduce further. Both 2 and 10 are divisible by 2. So we get 1 over 5. And there's our fraction. Now, how do we find a decimal from a percent? Well, let's remember that for our fractions, we used dividing by 100 to express percent. But instead of writing the number over 100 this time, let's do it a different way. Before I show you how to do it, let's see if we can figure it out together by first remembering what it looks like to multiply any number by 100. 1 times 100 is 100. 2 times 100 is 200. 15 times 100 is 1500, or 1500. As you can see, each time we multiply by 100, we're simply adding 2 zeros to the number. Or another way of thinking about it is, we're moving the decimal 2 places to the right. 25 times 100 is 2500. So, if multiplying by 100 simply moves the decimal 2 places to the right, what do you expect dividing by 100 would do? That's right. You'd move the decimal 2 places to the left. 2500, for instance, divided by 100 would be 25. Well, what about our 20% then? If percent means we divide by 100, then 20 divided by 100 would be what? Well, move the decimal 2 places to the left. Your answer should be 0.2. There's one more tricky complication we'll see when we get to problem 4, but let's get started. Our first problem gives us 10%. And wants us to find the equivalent decimal and fraction. Let's do the fraction first. 10% literally means 10 over 100. But that fraction can be reduced. We can divide the top and bottom by 10, giving us 1 over 10. That's our fraction. Now, let's find the decimal. Again, 10% literally means 10 divided by 100. So let's remove the percent sign and divide by 100. To divide by 100, simply move the decimal 2 spaces to the left. Our answer is 0.1. Our next problem gives us 90% to start with, and again we're finding an equivalent fraction and decimal. Getting the fraction first, we put 90 over 100, and we see that the top and bottom of this fraction are divisible by 10, so when we divide, we get 9 over 10, or 9/10. Now the decimal. To divide 90 by 100, we move the decimal 2 places to the left, which leaves us with 0.9. Next up, we're given 5%. Keep solving the same way. For the fraction, put the 5 over 100. Divide the top and bottom by 5, and you get 1 over 20. That's our fraction. Next, divide 5 by 100 to get the decimal. Move the decimal over 2 spaces to the left, and we get 0.05. Excellent, keep it up. This next one has an added complication. We are given 12.5%. Start out the problem in the same way. First, put the 12.5 over 100. Now, before we can do anything further, we must find a way to get rid of the pesky fraction in the numerator. Can you think of a way to do it? Well, since 2 halves equal a whole, we should be able to get rid of the fraction if we multiply 12.5 by 2. But we can't just multiply the numerator by something. That would change our answer. In order not to change our answer, we also have to multiply the denominator by 2. So go ahead and multiply the top and bottom by 2. We're left with 25 over 200. Can this be reduced? You bet. Both are divisible by 25. 25 divided by 25 is 1. 200 divided by 25 is 8. So our fraction is 1/8. Now the decimal. Once again, the fraction poses a problem for us. We need to get rid of it. But this time we get rid of it by turning it into a decimal. What decimal is equivalent to 1/2? You probably already know the answer, but just in case, here's how you would find it. 1/2 is the same thing as 1 divided by 2. So let's divide 1 by 2. Hopefully, you got the answer 0.5. So, if 1/2 is the same as 0.5, then 12.5% can be written as 12.5%. Now we can solve the same way as before. Divide 12.5 by 100, which is the same thing as moving the decimal 2 spaces to the left. Our answer should be 0.125. Next up, we have 50%. 50 over 100 is our fraction. Now reduce. Top and bottom are divisible by 50. We're left with 1 over 2. Now the decimal. 50 divided by 100 means moving the decimal 2 places to the left. That leaves us with 0.5. We're finished. For number 6, we have 25%. First, get the fraction. 25 over 100. Top and bottom are divisible by 25. So our answer is 1/4. Now the decimal. Move the decimal 2 places to the left. 25 becomes 0.25. And there's our answer. Next, we have another fraction. To start solving for the fraction, put 33 1/3 over 100. Now, what can we multiply top and bottom by to get rid of the fraction in the numerator? 3. Multiplying 33 1/3 by 3 gets us 100. Multiplying the 100 in the denominator by 3 gets us 300. So our fraction is 100 over 300. That's obviously reducible to 1/3. Now, on to the decimal. Starting once again with 33 1/3%, we must first get rid of the fraction. To do that, we convert the fraction into a decimal. 1 over 3 becomes 1 divided by 3. And our answer will be 0.3 repeating. So, if 1/3 equals 0.3 repeating, then we can rewrite 33 1/3% as 33.3 repeating percent. Now, divide by 100, moving the decimal 2 spaces to the left. We're left with 0.333 repeating. This can be simplified to simply 0.3 repeating. Next up, we have 20%. 20% equals 20 over 100. 20 and 100 are divisible by 20. So we're left with 1/5. Now the decimal. Dividing by 100 moves the decimal to the left 2 spaces. So we're left with 0.2. That was fast. Next up, 75%. Again, 75 over 100. Both are divisible by 25. We're left with 3/4. Next up, decimal. Move it to the left 2 spaces. 0.75. Done! Next, 66 2/3%. Put 66 2/3 over 100. Multiply top and bottom by 3 to get rid of the fraction in the numerator. That gives us 200 up top and 300 on bottom. This reduces to 2/3. Now the decimal. First, change the fraction part to a decimal. 2 divided by 3 is 0.6 repeating. 66.6 repeating divided by 100 means moving the decimal 2 places to the left, which leaves 0.666 repeating, which reduces to 0.6 repeating. Almost done. 1%. 1% as a fraction is simply 1 over 100. It can't be reduced. To find the decimal, just move the decimal to the left 2 spaces. It's 0.01. Last but not least, 250%. Start with the fraction. 250 over 100. Both are divisible by 10, so let's do that. 25 over 10 is still divisible by 5, so we're left with 5 over 2. Write this as a mixed fraction. 5 over 2 is the same as 2 1/2. Now the decimal. 250 divided by 100 moves the decimal to the left 2 places. This leaves us with 2.5. That's it. All done. Here are the answers to your power-up once again. Feel free to pause the video and rework any answers you got wrong. Now, pull out your notes page. Today, we are going to be discussing how to translate word problems into mathematical equations. Sometimes, this is simple and straightforward. 40 minus 5 equals 35 becomes 40 minus 5 equals 35. However, it's not always so straightforward. So, the first thing I want to put in our notes are some common phrases you'll encounter in your math word problems. The first phrase is twice a number. Hopefully, you already know that if you do something twice, you're doing it 2 times. So, twice a number means 2 times a number. Let's use n for number. And the twice becomes 2 times the n, or simply 2n. Here's another one. Half a number. This one can be written in one of 2 ways. You can write it as multiplication, 1/2 times n, or 1/2 n, or you can write it with division, n divided by 2. Remember, multiplying by half is the same as dividing by 2. Here's another one. 3 more than a number. That means a number, n, plus 3. Similarly, 3 less than a number would be the number n minus 3. Let's jot down one more. The product of 3 and a number. Product implies multiplication, so it means 3 times n, or just 3n. Now, let's try translating a few example word problems into equations. 4 more than the product of 5 and a number is 14. 4 more than should be written as 4 plus. The product of 5 and a number is multiplication, so it's written as 5n. Is equals, and 14 is just 14. So we have 4 plus 5n equals 14. That's the equation. And now you can go ahead and solve. Subtracting 4 from both sides gives you 5n equals 10. Dividing both sides by 5 gives you n equals 2. Let's do another one. 5 less than twice a number is 15. 5 less than means minus 5. Twice a number becomes 2n. Is equals, and then you have 15. So we have 2n minus 5 equals 15. Notice how the 5 less than had to be moved to the other side of the 2n. That's because 5 less than something is the same as something minus 5. Sometimes, if you get confused, changing the language of the problem first can help you write the correct equation. 5 less than twice a number is 15 can be stated, twice a number minus 5 is 15. If it helps you to restate the problem differently, you can do that. Okay, let's solve. Add 5 to both sides and we're left with 2n equals 20. Divide both sides by 2 and we have n equals 10. And that's our answer. Let's do a couple trickier examples. A video game costs $60 to buy at the store. It also has an online subscription fee of $10 per month. Write an equation for what it costs to play the game for a number of months. Use the equation to determine the cost to play the game for 3 months. Here, the number of months you want to play the game is the variable. Let's use m. For each month, you're charged $10. So let's put 10 times m. There's also a one-time charge of $60 for the game, so let's add that on to the monthly subscription price. So our equation is 10m plus 60, which will give us the total cost. Let's plug in 3 for the number of months. 10 times 3 is 30. Now add 60. The cost to play the game for 3 months would be $90. Let's do one more example. The two angles shown here are complementary. use an equation to find the value of both angles. First, we need to know that two angles are complementary if, when we add them together, they equal 90 degrees. So this angle here labeled x, when added to this angle here labeled 5x, will equal 90 degrees. Let's write that down as an equation. X plus 5x equals 90. We can add the 1x here to the 5x here, giving us a total of 6 x's. So this equation is now 6x equals 90. Dividing both sides by 6 gives us x equals 15. So let's use the value of x to find the value of both angles. This smaller angle has a value of x, so it must be 15 degrees. This other angle has a value of 5x, so it must be equal to 5 times 15, which is 75 degrees. That's it. We did it. Now it's time to open your textbook. To complete this lesson, start by doing the example problems provided. Try to solve them on your own before you look at the solution and the steps. Once you think you have the correct answer, check your work by walking through the steps, making sure that you arrived at the solution the correct way. Once you are done, you're ready to move on to your homework. See you next time!